Okay, section 1 of chapter 5 can get a little long, so I broke it into 2 sections. We're just going to continue the notes. I'm going to go back here so you can see this is where we finished that first part. Now we're going to continue. Still talking about waves and the nature of waves. Sunlight, let's go back here. Sunlight contains a continuous range of wavelengths and frequencies. Remember, the only way we can see things is because of light and because of those wavelengths. Now, I hope you guys have had an opportunity to play with a prism. If you've seen a rainbow, you've seen a prism, or you've used you've seen the evidence of a prism. A prism takes the light and it breaks it down into its colors. Now, remember, the lights in the classroom are white lights, but that can be broken down into all colors, Roy G. Biv, the rainbow. So the electromagnetic spectrum includes all forms of electromagnetic radiation. And here is all of the electromagnetic radiation, all the electromagnetic spectrum. And the visible light, what we see is this tiny little section in here, okay? So if you think about it, down here where you have wavelengths, where you have larger wavelengths, you have the radio waves, then you have microwaves, then infrared waves, then the visible light. Then ultraviolet, now remember this is what burns us, then we have X-rays and gamma rays. Okay, so this little section right here is all that we see. Okay, so this is an example of light coming into a prism, and prisms are triangular like this. White light comes in, hits this, and because of the way it hits at an angle and it breaks it down into its individual colors. And remember, Roy G. Biv. If you guys have been in my classroom and noticed, everything in my classroom is arranged by Roy G. Biv. And this is an example of the raindrops serving as a prism to break the sunlight down into a rainbow. Okay, go to page 140 of your textbook, and you need to work through those practice problems. Based off of velocity, speed of light, and wavelength. And there is an example in the book for you, and I have put number 1 as an example for you as well. Okay, the particle nature of light. The wave model of light cannot explain all of light's characteristics. Matter can gain or lose energy in small quantities called quanta. Okay, a quantum is the minimal amount of energy that can be gained or lost by an atom. Now, there is a scientist, Planck. He was really interested in this, and he came up with this constant of 6.626 times 10 to the minus 23rd JS, so joules times seconds. That was his constant, and we're going to use that as we continue talking about energy and waves. Okay, photoelectric effect. This is when electrons are emitted from a metal surface when light of certain frequency shines on it. So if you have a really shiny metal and you put a light on it, the reason it reflects is because of this photoelectric effect. Okay, Albert Einstein proposed in 1905 that light has a dual nature, that a beam of light has wave-like properties and particle-like properties. A photon is a particle of electromagnetic radiation with no mass and carries a quantum of energy. Okay, so now we're talking about the particle part of light. Okay, and this is the equation that we're going to be using. E photon equals hv. Okay, what was h? H over here is Planck's constant. That's that 6.62 times 10 to the minus 34. That's not going to change. And then there is frequency. So we're going to do some algebra problems. So go to page 143 of your text and do these practice problems. And here is 5A written out for you, and then you have your answers. Okay, now we're going to talk about the atomic emission spectrum. Okay, so have you ever been to a store that has had a neon sign? That neon sign is produced through the elements in the 18th column of the periodic table. Okay, those are all elements. Specifically, we are looking at number 10, neon. What happens when you put electricity through those elements is they light up in different colors. Okay, so light in a neon sign is produced when electricity is passed through a tube filled with neon gas. That electricity excites the electrons and they start jumping around. When they start jumping around, they give off light. Okay, so you can see we are going to do an experiment here in probably tomorrow based off of this. You can see, okay, this is hydrogen gas. As it comes through, this is just a circle with a split in it. As that light hits this prism, it is broken down, just like the sunlight hits a prism and it's broken down into Roy G. Biv. Okay, you can see that hydrogen is only broken down into 4 separate wavelengths. Each element has its own wavelengths. Okay, every element does not contain every wavelength, does not contain every color, but it is a combination of colors. So hydrogen, when it's broken down, is broken down into these specific 4 wavelengths. Okay, the atomic emission spectrum of an element is the set of frequencies of the electromagnetic wave emitted by the atoms of that particular element. So this particularly is the the atomic emission spectrum specifically for hydrogen. Now if we had helium up here, they would be in a different spot. If we had carbon up here, we would have different wavelengths listed. Each element has its own wavelengths. Okay, oh man, I just gave you the answer. What is the smallest amount of energy that can be gained or lost by an atom? Quanta is the answer, of course, because I gave it to you. Next one. What is the particle of electromagnetic radiation with no mass called? Yep, photon is the answer. Very good. We will continue to study light, and hopefully I will answer all your questions. See you later.